1, 2, 1, 2. Okay, we got it. We got it back. That's annoying. Hear me now. I'm going to assume yes, because I feel like it is now working properly. Yep, got me. Cool. Okay. Sorry about that, guys. I'd got no idea why that wasn't working. All right. I think we're back everywhere. Is that true? No, that's not true. Um, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. Oh, we've got 2 on this one now. Okay, cool. Sorry about that, guys. Yeah, don't know what the cause of that was. Right. Anyway, so practicing our probability that we did on Friday. So remember, there were two kind of major things we looked at on Friday. The first of which was the probability equation. So A or B is A plus B minus the middle bit, A and B, minus the intersection. We also looked at conditional probability. We said probability of A given that B has happened is A and B, the intersection, divided by B. So we've reduced the sample space from the whole sample space is now reduced down to B. And we also looked at mutually exclusive where A and B is 0, which turns the top equation into A or B is A plus B. And we looked at independent events, which is when A given B is A. And that turns the second equation into A and B is A times B. So that's everything we've done so far. We also looked at Venn diagrams. Remember, the whole probability is everything. We looked at different regions, and then we looked at our tree diagrams as well. All right, so we're going to do a few questions to start with today, just to make sure everybody's happy with probability. So I've got a question up on the screen now. It's worth 6 marks. Let's give you guys 6 minutes. I think you will want to be drawing a Venn diagram for this one. So try draw your Venn diagrams and see how you get on. Comment your answers as you get them. All right, so 6 minutes starting from now. Right. A bit worried that I think things are lagging. Yeah. Can you guys, is the stream okay? It does look like we're jerking around time-wise a bit. Um, Let me know. I don't know what I can do to fix it, but see what you will say. Hmm. What can I do? What can I do? Is it all right? Is it doable, or shall I try and reset things? Yeah, we'll go ahead and we'll see what happens. If it gets much worse, let me know. All right, so go draw a Venn diagram. There we go. So we've got A and B. As long as the audio is alright, that's what matters really, because I can glitch around all I like, and the whiteboard's gonna be a bit glitchy anyway. Okay, so the middle bit, A and B is 0.2, so we'll put 0.2 in there. We know A is 0.4, so the rest of the A circle is also going to be 0.2, and we know B is 0.35, so we got 0.15. Cool. So we want to try, and we may as well do the outside, so that's 0.45 out there. Okay, so we want to find A or B, so we need to add all the bits together. So we're going to get 0.55. Not A and not B is the outside bit, so 0.45. B given A, or B given A will be B and A divided by probability of A. So that's going to be 0.2 out of 0.4, which is 1/2, or 0.5. And not A given B is going to be probability of not A and B out of B. So the denominator even is going to be 0.35. And the numerator is not A and B, 0.15. So 0.15 out of 0.35 gives us 0.443. I'm going to round it a bit there. So 0.43 for that one. Okay, what do you guys get? 3/7. Yeah, that's probably a better way of writing that one, actually. Yeah, thank you, Harry. 3/7 of that one. And George, yes. George, yeah, okay. So Harry, yeah, looks like your part C was wrong. And Jake, yeah, good by the looks of it. Yeah, cool. Oh yeah, you've corrected there anyway. Good. Okay. So moving onwards. The next question, similar kind of idea. I'll just make it a bit bigger. Could you guys try this? So it's a bit of a bigger question this time. So we've got an 8-mark question. So let's give you guys 8 minutes on the timer. Yeah, comment if you need help and comment your answers. Cool. It seems to have sorted out its choppiness. So yeah, cool. Right. I don't see many answers posted though, but hopefully you guys have got on okay. Hopefully you guys have got on okay. Cool. All right. So we've got 3 events this time, and we want to draw a Venn diagram. So nice. Maybe that's a bit excessive. Nice big Venn diagram. We've got J, K, and L. Cool. So J and L are mutually exclusive, so those need to have no overlap, as I've kind of drawn already. J and K 0.1. We know the rest of J is all of J is 0.25, so this must be 0.15. You don't know much more than that. We know K and L are independent. So because they're independent, means K and L is K times L. So I can find the middle bit, the intersection or the intersection between K and L, by timesing their probability together. So I'm going to do 0.45 times by 0.15. And I get 0.0675. It seems awfully small, but yeah, that's it. Okay, so the rest of the K circle is going to be 0.45, take 0.1, take 0.0675, gives me 0.2825. And the rest of the L circle, well, that's 0.15, which gives me 0.0825. Horrible numbers. Right, we probably want to do the outside as well, so if I add all these up, we get 0.6825. And then 1 minus that gives me 0.3175. Oops, deleted everything. Cool. Right, what do you guys think? You agreeing with this so far? Alright, so first bit of the question is asking us for J or K. So we're going to add up all the regions that are J or K. So this bit, this bit, this bit, and this bit. So add those together. And you should get 0.6 for that one. Next one, not J and not L. Okay, let's rubbish. What have I done? I shouldn't have done that. Okay, let me delete those little dots. That's right, Becky. Just try and catch up when you can. Okay, so we want not J and not L. Okay, not J and not L. Well, this bit is not J or L, and so is this bit. All the rest of the bits are either J or L. So add those two together. 0.2825 plus 0.3175, and we get 0.6 again. Next one, J given K. So that's going to be j and k out of k. So j and k is 0.1. The whole of the k circle was 0.45, which gives us 2/9. And the last bit, probability of k given not j and not l, is going to be k and not j and not l divided by not j and not l. So a bit more confusing, this bit. So I'll go over it in yellow. So k and not j and not l. Okay. Well, not j and not l, we've already looked at those two middle bits, and we want k as well, so it's going to be 0.2825. So that's this bit here. Divided by not j and not l. Well, we found that earlier was 0.6. So if we do that calculation, we get the lovely answer of 113 over 240 for that one. Cool. Have a quick read through and check you guys are up with that. I'm just going to fill up the Becky's on the register. Still no Tom, still no Isaac, and still no Lucas. Interesting. That's all the second years. Okay. Cool. So don't think there's any questions. I think there's one more maybe he needs to do. Yeah, one more to do. So could you guys try this one? It's a 5-mark question, so I'll give you guys 5 minutes to do it. Cool. All right, it's 5 minutes starting from now. Okay, cool. So, yeah, I quite like this question. I think it's quite interesting. So, got two students late for school. The events A and B are defined like this. So A is Anna's late and B is Bella is late. So we can probably do a Venn diagram for this. So I'm going to assume that they aren't mutually exclusive, but if it turns out they are, we can always redo our Venn diagram. So unless it tells you, you just have to kind of assume that it's not mutually exclusive. But there is a bit of a risk in that. So not A and not B is 0.1, so that goes on the outside. And we've got 0.3 for all of A and 0.7 for all of B. But we don't know any more specifically. So on a randomly selected A, find the probability that both Anna and Bella are late for school. Yeah, I think in this case we're going to have to just times them both together. So 0.3 times 0.7. I suppose. Is there any way around this? Yeah, for 1 mark, I think that's all it's going to be. So 0.21 for that one. Okay. Next one. Yes, I think all the way through we're having to assume that both of these students are independent. We're having to assume that so that we know what the intersection is for this one. So let's try and work it out. So yeah, if I say the middle bit, then if I just clear up my Venn diagram a bit more. There we go. Middle bit there is going to be 0.21, which means the rest of Anna's circle is going to be 0.09. The rest of Bella's circle will be 0.49. I think this, yeah, interestingly worded question, this one. Okay, so Anna was late given, so we want the probability of A given B. So we know the equation is A and B out of B. So we can work out those ones, so that'll be 0.21 out of 0.7, which will give us 0.3. Right, where this gets interesting is part C. So the teachers suspect that it is linked in some way. I mean, we've kind of assumed all the way through that it is linked, though. We've said we think it's independent. So I guess No, I don't think this is right. No, let's start this question again. I think that is all wrong because otherwise, yeah, we can't assume that it's independent when part C is asking us to test if it's independent. So please forget all of that. We're going to redo this. We need to be cleverer than that. Right. A and B. Sorry, guys. Just kind of dawned on me at part C that's not the way we can do it. So not A and not B is 0.1. So we know this section outside is 0.1. Okay, so we can say the rest of the circle, the whole middle bit, all this stuff in the middle here, plus 0.1 should be equal to 1. So A or B plus 0.1 equals 0.9. So I know that A or B, sorry, that should say 1. I've got thinking one step ahead there. So A or B should equal 0.9. Okay. And I know that A or B is A plus B minus A and B, should in that case be 0.9. And I know A and I know B, so 0.3 plus 0.7 minus the middle bit is 0.9. So we get 1 minus A and B is 0.9. So A and B is 0.1. That's much better. So the middle bit should be 0.1. Okay, so the A circle should be 0.2. The B circle should be 0.6. And this feels a lot better now. Cool. Right, so let's get rid of that workings. Hopefully that makes sense to everybody. In the other one, yeah, as Billy said, the probabilities don't actually add up to 0.1. Or they don't add up to 1, which is bad. Cool. All right, so we got that. So probability that they're both late to school. So part A is 0.1. Part B, Anna is late given Bella is late. So again, A and B out of B. That's 0.1 out of 0.7, which is 1/7. And then part C, we're testing if they're independent. So independent if A and B is A times B, which it won't be because that's what we did wrong earlier. So 0.1, does 0.1 equal 0.2? Sorry, that's wrong. Does 0.1 equal the whole of A, 0.3, times the whole of B, 0.7? No. So they are not independent. So if they're not independent, it means that they are dependent. So Anna being late is dependent on Bella being late and so on and so forth. So yeah, they are linked. So the suspicion, let's write this in big, the teacher's suspicion is valid. They are dependent. Cool. Hopefully everybody's all right with that. Anyone got any questions? Sorry for doing it wrong the first time, but easily done. All right, so for the rest of this week, we're going to be working through at least one past paper. They're meant to take 2 hours, so we hopefully will get through one. And it will take a bit longer because I'm kind of giving you guys time and then coming back and going through it. Yeah. So I picked one of the Mad as Maths papers, which you guys can take off. I think this is paper. Which paper was it that I downloaded? I think it was paper G. Let's just have a quick look at my downloads folder. I can actually see it now. Um, yeah. All right, paper J. Cool. Right, so this is Mad Ass Maths paper J, which looked quite difficult. So this is Mad Ass paper J. So you guys can tick this off of ones that you don't need to revise. Maybe you've only got a week, so I would advise that you do at least 2 past papers this week, at least, because it is an important result. This one. Okay. Anyway, so we're going to try and work through this one today. So we got a question per slide. Start off with this one, which is a 7-mark question, all about surds and indices. So let's see what you guys remember about surds and indices. So timer starting now. Cool. Right, let's go through this one. So, yeah, the first bit we're talking with surds. We got root 108 plus root 3. Well, root 108 is 6 root 3. So we got 6 root 3. Make that a bit smaller. 6 root 3 plus root 3 is 7 root 3. Nice and easy. Then we got root 6 plus, so we need to rationalize the denominator in this one. So remember, times by root 2, take 1 on the top and the bottom. So we're going to get square root of 12 minus root 6 plus root 6 minus root 3 all over 2 minus root 2 plus root 2 minus 1. So if we sort that out, we got root 12, take root 3 over 1. And root 12 is the same as 2 root 3. So 2 root 3, take root 3. So the answer to this one is just root 3. Cool. Right, let me get rid of that because I don't have any space. Okay, and the last bit is saying solve this equation. So I'm going to square root, no, I'm going to cube root both sides. So I'm going to say 5 minus x equals 8 to the power 2 over 3. So I'm going to cube root 8 and get 2, so 5 minus x equals 2 squared. So 5 minus x equals 4. So x equals 5 minus 4, x equals 1. And that's how we do that one. Cool. Yeah, any questions, guys, on any of those bits? No? Okay, next question. So 7-mark question. If you guys could try this one. We're now talking vectors. So if you get stuck with this, try and sketch it. Sketching always helps with vectors. So another 7 minutes. Go. cool. So as I said before, with vectors, always sketch them. So we got relative to an origin. There's O. We've got A. I know this is the wrong place for A. I don't care. A has coordinates -2, 4. Okay, point B over here. And we know that B to A is 5 minus 1. Is that root there. Oh, and they're mutually perpendicular unit vectors, I and j. Okay, cool. Well, that's all that tells us is I and j. Right, determine the distance of B from the origin. So we want to try and find OB, and we also know OA. So if I want to go from the origin to B, which is basically what we're trying to find, I can go O to A, and then A to B. So OB equals OA plus AB. Now OA we know is -2, 4. AB, we don't know AB, but we do know BA. So if we reverse BA, we get AB. So we know this is going to be plus -5, positive 1, and that will give me OB. So OB is going to be -7, 5. And if I want to find the distance of B from the origin, I can just find the modulus of that vector. So -7 squared plus 5 squared, and then square root it. Which gives me root 74. Right, so that's my first bet, is that the length of that one there is root 74. Okay, let's make some space so I can do the next bit. So we want to calculate the angle OAB. So the angle OAB is this angle here in yellow. So I'm going to try and find this angle. So we're going to be using the cosine rule, and we need to know the length of each of these sides. So the length of OA is going to be 2 or -2 squared plus 4 squared square rooted, which is going to be root 20. So let's add that to our sketch. We know this side here is root 20. And AB we know was, well, BA we know was 5 minus 1. So we can say that's the size of that one is going to be 5 squared plus -1 squared, and then square root that, which gives me root 26. Okay, so to summarize what we've got in this triangle, got root 20, root 74, root 26. We want to try and find this angle here. So it's going to be a case of the cosine rule. And remember, the cosine rule says cos of A is b squared plus c squared minus 2bc over, I've totally forgotten this now. Cosine rule. A squared plus c squared divided by minus. Yeah, well, my brain's not working. Let's go from the normal one and convert it. Yeah, what was I thinking? So okay, so the cosine rule we want is cos A is b squared plus c squared minus a squared over 2bc. So ignore my little brain freeze just now, that's what we need. All right, so cos of our angle is going to be root 20 squared plus root 26 squared minus root 74 squared divided by 2 lots of root 20, root 26. Okay, so to the calculator we go. So we get 20 plus 26 take 74, which is minus 28. Divided by 20, so root 20 times 26 times by 2 gives me 4 root 130. And we're going to do arc cos of that. Which gives me an angle of 127.8 degrees. It sounds about right to me. So a 127.87. So let's round it up to 0.9 degrees. Cool. Anyone got any questions about that? Right, I reckon we can hopefully get one more question done today in the last 15 minutes. Which will be this one, yes, since it seems possible for 15 minutes. So we've got 6-mark question, all to do with, looks like a differentiation question to me. So something to do with differentiation and tangents and normals. Okay, 6 minutes starting now. the last one for today then. So we're told here's y, find the equation for the normal when x equals 2. So we're going to write y as root 2 x to the half. Which you've got to be careful with, see that root sign extends over both those things. The gradient dy dx is going to be half root 2 x to the minus half. Mic on my head, cool, thank you. Yes, just what I said just now, be careful with this one. Y is root 2x. The root extends over both those bits. Do we get this if you differentiate it? Good. Put in x equals 2. So we get dy dx equals root 2 over 2. X to the minus half, so we're going to get 1 over root 2. So those are going to cancel, and the gradient is just going to be a half. Okay, so that's the gradient of the tangent. So the gradient of the normal is going to be minus 2. We know our x coordinate is 2. We just need our y coordinate. So if we put 2 in, we get y equals root of 2 times 2, which is root 4, so y also equals 2. So we're going to put that into a line equation. So y minus 2 equals the gradient minus 2 x take 2, which leads us to y equals minus 2x plus 6. It's not that bad. Bit weird with all the roots and stuff, but otherwise fine. Right. Anyone got any questions? Okay, we're gonna move on. 5 minutes left. Oh yeah. I think we'll call it a day for today. We ain't gonna get anywhere with this one, so got here. So on Wednesday we'll be continuing this. As usual, make sure you guys are uploading your assignments every Friday and your skills checks to the Moodle website. Let me know if there's any issues with that. And yeah, this week I'll be marking your last week's assignment and your the work you did over Easter for me. So make sure that's there as well. Cool. Right, take it easy, guys. Make sure you get some revision done and email me if you need any help. Because remember, your exam is next week, so get revising. That's your exam for this year. So it is an important exam. So start revising. Cool. Right, take it easy, guys. See you Wednesday.